Okay, so what we're going to do in this video is it's part 3 of chapter 5, where we're going to be able to find percentiles that do not land exactly on z-scores, on standard deviations. And so there's some things that we have to do. The first thing you have to do is you have to make sure that you provide evidence and how you're going to do this, okay? I don't want calculator talk written. That's not important. It's important to have pictures and the needed information. So the first thing you're going to do is you're going to draw a curve. And you don't have to label everything. You just have to draw the curve. And you're going to put the mean there. And then you're going to draw a line for the cutoff. And then you're going to shade if it's above. And then if it's below, you're going to shade the other side. Okay. The other thing that you want to do is you're going to say with n, because it's following the normal model, you're going to put your mean right here and the standard deviation right here. If you have those two pieces, you have enough evidence that you understand the problem and you will get full credit. So again, you're going to shade it above or below, and sometimes there's going to be shading in between. And you're going to write what the n is, mean standard deviation. And then a lot of times I'm going to put, let's say the mean was 50, but this cutoff score was 70. So I'm going to put those numbers also. So right here, this is enough evidence. Now, to do the calculator steps, you're going to hit second and then vars. And that's going to take you to distribution. And you're going to always want to use normal CDF. Okay? The C stands for cumulative, and so we want to use CDF. We're never going to use the PDF. So I'm going to do CDF, and I hit enter. And it's going to walk you through some questions. It's going to ask you what the lower number is, what an upper number is, what the mean is. This one right here, that's mean. And then this one right here is standard deviation. Okay? This right here is just saying negative infinity. We just have to put a really small number or a really big number in. Okay? If you're looking for an actual value that gives you a percentile, we're going backwards, we're going to use inverse norm, and we'll talk about that one also. Okay, so let's do a couple examples. So, we're going to draw our picture. We're going to put our mean here at 15, and it says numbers above 18. So 18 would be around here, and I shade above. And again, even though the problem says this, I'd like you to get in the habit of writing this, because a lot of times people forget it and then they lose a point. Okay, so let's go through this process again. Second, vars, normal CDF. Okay, lower is left. The left side of my shaded region is right here, and that's 18. The upper is way over here somewhere. This is the upper. And so I just pick a really big number. My mean is 15, and my standard deviation is 2. We hit enter and enter, and one more time. And so I get 0.067. You can write it as a decimal. If you want to change it to a percent, it would be 6.7%. I would not round this to 7%. I would always keep an extra decimal. Okay, let's look at the next one. Same idea. Draw a curve. Put 15 in the middle. This time it says below 10, so 10's on the left somewhere, and I'm going to shade below. And again, we're writing our normal model information. Okay, so now second distribution, normal CDF. Okay, lower this time. Our lower this time is a really small number here. So a lot of times people will just do negative and then a really big negative number. And then our upper is this right side. It's the upside of the shaded region, the right side of the shaded region. So that's 10. Our mean is still 15, but this time our standard deviation is 4. And so this one is 0.106. And again, you can leave it like this, or you can say it's 10.6%. Okay, and what this means is that on a normal model, 10.6% of people or results would be 10 or below. Number one is saying that on a normal model with similar sample size, 6.7% of people would score an 18 or higher. Okay, we got 2 more to do real quick, and the bell just rang, so I gotta hurry up. Okay, so now let's do the next one. Same idea. 15. This time it's between 11 and 21. So 11's right here, 21's over here, and I'm going to shade in between. Still going to write my normal model information, and now I'm going to go to my second distribution. Go down to number 2. My lower again is the left, and my lower this time is 11. My upper is the right, and my upper this time is 21. My mean is still 15, but this time my standard deviation is 3. And so I get 0.886. So again, you can leave it as a decimal or write it as a percent, but this essentially says that 88.6% of results are in between 11 and 21. That's what that's saying. Okay, problem 4 is totally different because what we're doing is I'm telling you the percent, and we have the 90th percentile. So what that means, let's look at what this picture means. A lot of you are familiar with, that's kind of crooked, your SAT scores, and you kind of recognize what percentile you're in. If you're in the 90th percentile, that means that 90% is below that line. So this line is the cutoff where 90% is to the left and 10% is to the right. Okay? So if I want to find the 90th percentile, what I'm essentially looking for is I'm looking for this value here. These values that were cutoffs that gave me percents. So what we're doing is we're working backwards. And so working backwards is the inverse norm. Okay? I'm still going to write my number. And so now I'm going to go second distribution, and I'm going to do inverse norm. And when it talks about area, inverse norm, on a lot of these calculators will only do the area to the left. Some of you have a newer version, and I've noticed recently that it'll let you do left or right, but I'm always going to do the area to the left because most of our calculators will only allow that. You have to type the area as a decimal. If you do not type it as a decimal, it's not going to work. It's not going to give you the right answer. And so our mean is 15, and our standard deviation at 5. And so what that tells us is that a score of 21, let me use red. A score of 21.4 is going to give you 90% of the data. So if you score 21.4 or higher, you're in the top 90, you're in the 90th percentile. Okay, so we will definitely practice this, but you got to make sure you draw the picture. I do not want to see anybody writing inverse norm or normal CDF and then writing down what you plug in the calculator. Okay, your picture is what paints it so that I understand that you know it.